Welcome back. Last time, we talked about how to use an oscilloscope to measure and monitor one signal on a single channel. Today, we're going to talk about how to effectively use an oscilloscope to monitor multiple signals, as well as how to use an external trigger. Recall that our oscilloscope has two inputs for two different signals, as well as a trigger input. Last time, we connected channel 1 to one of these function generators. So we're going to do the same thing today. I'm going to use a second function generator as our signal for channel 2. Function generators will normally have an additional output known as a sync or a trigger output. I'm going to use this output from one of the function generators as my external trigger. So here, I'm using all three connectors for the oscilloscope.
Now that I've connected all the signals to my oscilloscope, I'm going to open up the oscilloscope software just like last time. I can see that channel 1 is already being displayed. Let's make sure to use the correct multiplier setting for the probe. Now, I'm going to turn on channel 2 as well. Again, be mindful of the multiplier setting. Let's adjust the independent vertical scales for channel 2 so that channel 2 comes into view. For the function generators I'm using right now, I've set both of them to output a waveform at 100 kHz. Channel 1 is outputting a sine wave, and channel 2 is outputting a square wave. Because the two function generators are not calibrated against one another, the two frequencies they are outputting are slightly offset. That explains why you see one signal drifting relative to the other. Depending on your preference, you can overlay the two channels, just like this, or you can display them side by side, like this. When you're playing around with the signals, make sure you set the trigger level appropriately. Right now, I'm triggering on channel 1, which explains why channel 1 stays steady as channel 2 drifts. If I'd like, I can trigger on channel 2 instead. Notice how channel 2 is staying steady and channel 1 is drifting. Again, the rising and falling options in the trigger and the single mode are still valid for both channel 1 and channel 2. Channel 2 comes with its own set of markers. These are independent of the markers that we had for channel 1. We'll still only use one set of horizontal markers, because the timescales for the two channels are the same. For the external trigger, right now, it's connected to the trigger output from the function generator that is supplying the square wave for channel 2. If I switch to using that external trigger now instead of triggering on channel 1, I can see that the square wave now stays steady as channel 1 drifts. This is similar to just triggering on a voltage level for channel 2. However, in certain applications, this will prove to be more useful. Just like before, I can still use the history and averaging features to see how the signals change over time. If I turn on the history feature, I can see how channel 1 drifts as channel 2 stays steady. When I use the averaging feature, I can clean up the noise. Be careful when using the averaging feature when you're using two different signals like this. Let's see why. If I go back, triggering a channel on the sine wave, and then turn on averaging, I can see that the edges of the square wave are somewhat distorted. This is because we're now averaging square waves that are slightly offset from each other, causing this slope. Notice here that instead of displaying voltage on the vertical axis and time on the horizontal axis, I can plot the two channels against one another. All the scaling settings and offset settings apply to this output as well. I'm going to change the output of my function generator now to a sine wave to see what happens. This pattern that we now see in purple is known as a Lissajous figure. Notice how, when the sine waves are 90 degrees out of phase, we get a perfect circle. As the phase shift changes over time, the circle appears to get squished and then expand again. Using tools like these that we've covered now, you can learn how to monitor different signals against one another.
Now, you should know how to use an oscilloscope to measure multiple channels at once. Next time, we'll cover how to use an arbitrary function generator, similar to the ones that we used today.